Okay, this is part 2 of mechanisms of evolution and examples of genetic drift. The founder effect is the first example. A founder effect occurs when a new colony is started by a few members of the original population. Small population that branches off from a larger one may or may not be genetically representative of the larger population from which it was derived. Only a fraction of the total genetic diversity of the original gene pool is represented in these few individuals. Okay, now I'm going to give you an example of the genetic drift.
In this tutorial, we will talk about several topics in evolution: the founder effect, bottlenecking, and genetic drift. Our story begins with a small island and a small group of 7 people, 43% of which have an unattractive condition that causes them to be bald. Here is a section of the mainland population. The percentage of bald people is much lower, only about 10%. The small population of humans arrive on the secluded island far away from any mainland. Keep in mind that this group of people is a very inaccurate representation of the percentage of people in the normal population with this hairless condition. The small group of founders arrives on the island and begin to get to know one another. The small amount of humans procreates and procreates and procreates until their population grows to a number supported by the conditions on the island. As procreation continues, notice the increasingly high number of bald people.
After another survey of the population, we can see that there is a much higher percentage of bald people on the island. This is a result of the founder effect. Because the founders of the island had a much higher percentage of people with the genetic condition, and therefore their descendants do too. Suddenly, a natural disaster comes and wipes out all of the population, except for a few survivors. As the rubble is washed away, and life begins to flourish on the island once again, the survivors begin to rebuild their population, with an even higher percentage of bald people than before. This is a result of bottlenecking. There was already a high percentage of the condition on the island before the disaster. When nearly all the population is wiped out, the survivors' genetics are passed on to their descendants, who represent an even higher percentage of the bald people than before the disaster.
Woohoo! Bald people rule! So I hope you liked that video. I hope you understood it a little bit more. It basically started off with mostly bald people in a population. They went off to this island, and they resettled the island. And there was a few people with hair, but mainly bald people. But on this new island, you had the majority of the people being bald, and just a few people with hair. And then over time, they reproduce, and what's going to happen? The majority of the population, which was bald, is going to increase, and you are going to have a lot of bald people. Yeah, a few hair people too. However, then we have the bottlenecking effect, which is a natural disaster like the tidal wave coming through, and the tidal wave would knock them out, knock out the majority of the population. However, still the survivors that are left are a majority of bald, which therefore would increase the population even more because they're the ones that survive. Sort of like natural selection takes over again. The majority of the gene pools is bald people, so they would be the ones that reproduced. We just talked about this. An example that might give you a better visual of the bottleneck effect is, let's say you take a bottle of Skittles there, you put them in a bottle, and you dump out just a few of them. Let's say you only dumped out the yellow and the blue ones, and by chance, and then set them aside. Over time, the new population of Skittles, if they could reproduce, would just produce yellow and blue ones because that's what's in their gene pool. Another example that actually happened in real life was with the northern elephant seals having reduced genetic variation. This is because humans inflicted heavy hunting on in the 1890s. They reduced their population to as few as 20. Their population has since rebounded to over 30,000, but their genes still carry the marks of the bottleneck. They have much less genetic variation than the southern elephant seals that was not so intensely hunted. This just gives you a chart of what happens. Mutations. The fourth mechanism of evolution are inheritable changes in the genotype. They provide the variation that can be acted upon by natural selection. Mutations provide the raw materials on which natural selection can act. Only sources of additional genetic material in new alleles. Mutations can be neutral, they can be harmful, or they can even be beneficial, giving an individual a better chance for survival. Antibiotic resistance in bacteria is one form. Mutation can be classified as a change in DNA, the hereditary material that we've been talking about all along this year. An organism's DNA affects how it looks, how it behaves, and its physiology. So a change in an organism's DNA can cause changes in all aspects of its life. There are different types of mutations. Some are called somatic mutations. They occur in non-reproductive cells and won't be passed on to offspring. For example, the golden color on half of this red delicious apple was caused by a somatic mutation. The seeds of this apple do not carry the mutation. Therefore, if you plant the seeds, you're not going to get a half and half apple. You will get the golden apple, okay? That's because it was a somatic mutation. The seed won't carry the mutation. Mutations that mature to a larger scale that can be passed on to offspring. They're called germ-line mutations. A single germ-line mutation can have a range of effects. One, no change in the phenotype. Phenotype, if you remember, is what an individual looks like. So that wouldn't be this. That's a major change in the phenotype with that poor looking frog. Another change that can happen is small changes occurs in the phenotype. It looks like that cat has a little problem with his ears. Or you can have some huge changes in its phenotype. And this happens, if this happens and they are big enough, they can cause death. Mutations that cause death are called lethals. Some really important phenotypic changes like DDT resistance in insects are sometimes caused by single mutations. Okay, lethals, it doesn't get any more negative than that because you die. So hopefully we don't have those mutations. Some causes of mutations. DNA fails to copy accurately. That's just by chance. Two external influences can create mutations. Exposure to radiation or specific chemicals. That would be an example of an external influence. And I don't know what happened to the snake. Maybe it was external. Maybe its DNA just didn't fully copy. I don't know, but something happened to that snake because I have never seen a two-headed snake. Okay, so I hope you understood the PowerPoint. If you have any questions, go ahead and email me. Otherwise, have a great day.